presentation about applying conditional information in guiding diffusion-based method for anime style drawing. My name is Bao, and this thesis was supervised by Dr. Minh Thị Phương from ICT Lab and Dr. Trần Quốc Long from UAT Institute of AI as external supervisor. My presentation will consist of four main parts: the introduction, material and method, result and discussion, and finally conclusion and future work. Now first we'll come to the introduction, where we will talk about the background information, the current problem, and objective. Now as you can know, currently the digital art market has become more and more bigger than ever. In 2023, it is estimated to have a market value of $65 billion. And there is also a transition from traditional art to digital art, as hardware like iPad and drawing tablet or professional drawing apps like Twitter, Clip Studio Paint or Photoshop has become better and better. This also has democratized in art creation, helping everyone can create art and share together. Still, there is a current problem in traditional art. It is a time-intensive process. There is a lot of steps in making a good piece of art, including drawing rough sketch, filling the line, and coloring and finishing steps. It also has a high skill barrier. A professional artist has to train for many years to become to have a job in the work field nowadays, and there's also a consistency challenge. When you're working with multiple people, it is hard to keep the detail of the same character consistently between people and people. And finally, it's a scalability issue, as the demand for anime-related material become more and more higher. It is putting a tremendous pressure on artists, and it also costs a lot of money to chasing the demand. But there currently an existing work to help artists in aiding their process. IP adapter is an example. It uses a reference image and a text description combined together into a model that can create an image that follows both of them. Here you can see it is the example generation from IP adapter. The pro of this method is that the generated image is really high quality, and the generated image follows very good to the reference image here. The con of this is that the reference must be a completed image, which is not flexible. When artists just want to try different styles, they cannot gather many different finished art to input into the model. Also, the model is really heavy, so that it costs a lot of time to just generate in one image. To combat this problem, I introduce a different conditional information which has a facial landmark and textual caption. Facial landmark is a list of points that can show the position of part on face like eyes, nose, mouth, and the barrier bounding of the face. The textual caption is a list of words that describe the image. Still, because it is different from human face, animal face has a different style that can be very depend on artist, art style, and different technique. So it doesn't have a consistent structure. Therefore, I introduce a 24-point facial landmark that has 3 points for each eyebrow, 5 points for each eye, 1 point for nose, 4 points for mouth, and 2 points for the left and right edge of the face, and 1 point for the chin. This, even though simple, can be used to describe the face among different art styles, so it is suitable for this process. So the objective of this is to develop a landmark guide diffusion framework that can balancing between structure and style to generate quality anime face drawing. And we also want to demonstrate the effectiveness in preserving the structure while also allowing stylistic freedom. Now come to the material method, where we will go deep into the dataset, the facial landmark, and the textual caption. The dataset we use is the Danburu anime face dataset, where it has 30,000 anime styles per image. The resolution of each image is 512 by 512, and each image has a label that includes the text caption and the facial landmark. Now, since we want to generate one anime face per image, we must also remove the image that are not fitted to trend, which are images that have multiple faces, like this and this here, or image that has face too small compared to overall image, like this over there, because it will affect the landmark as it is not distributed properly, or there are more than one face, which will affect the training process. So after removing this image that's not fitted, we are left with 26,000 images to train. Here is the distribution of the left and the right edge of the face and the chin. As you can see here, horizontally the face is relatively, say, in the middle of the image, but vertically the face is slightly turning to the left more compared to the right. This is known as a phenomenon called left gate bias, where right-handed people usually draw face turn to the left more, and left-handed people usually draw face turn to the right more. To combat this problem, I randomly flip the image vertically so that there is no bias in face turning direction. Now for the text caption is a list of words to describe of image. In total, there is a total of 5,469 unique words in the whole data set. Each caption has a minimum of 5 words and a maximum of 54 words. On average, each caption has 24 words to describe it. Here is the word file that shows the distribution of the frequency of each word in the data set. As you can see here, the most 5 popular words are bang, long hair, smile, open mouth, blush, which used to describe the hair or the shape of the mouth. Now here is the cumulative word frequency distribution among all over 5,000 words here. As you can see here, it is the long tail distribution, where nearly only a few hundred words take up nearly over 80% of the total distribution, as you can see in the left here. Luckily, the rest of the few thousand words is only describing accessory or clothes, which are not necessary in generating face, so we can ignore that. Still, even among the 800 words, the distribution is not evenly distributed among all these words. This is why we apply a step called randomly remove, where in each caption we find the most popular word, the word that in the 30% most popular word, and we randomly remove them so that the model is less biased towards the word and can learn all words equally together. As you can see here in the cumulative word frequency distribution, after we remove, it follows a linear trend, which means each word has a similar importance among all the data set. Now let's come to the method where we talk about the diffusion model, the text embedding model, the noise prediction model. Diffusion is a kind of generative model where it has 2 processes, the forward process and the backward process. The forward process is that we start from the original image and we iteratively add noise to the image until it reaches an equilibrium state where it's nearly a Gaussian noise. After that, the backward process is to use the machine learning model to predict the previous state using the current state. In the original paper, the author has shown that we don't need to find the previous state using the current state, but we can find the noise added in that state and we subtract that to the current state, and we can also achieve the previous state. So this diffusion model can be turned into a noise prediction model where we will try to, in each step, we will try to predict the noise that added that, and we subtract, and after t step, we will come back to the original image that we want. And here is the text embedding model. To incorporate text into an image, I use OpenClick. OpenClick is the model that uses contrastive learning, which is a kind of training that can try to put the text and the image in the same place in the vector space as long as those two describe the same object. Here, the text encoder encode n text into n vector here, and the image encoder encode n image into an n vector here. And we create also a matrix of n by n, where x cell is the dot product of the vector from the text encoder and the image encoder. The model OpenClick is then trained to optimize such that the diagonal has some graded value because it is the dot product between two related terms, so that it must be bigger than the other cell. Now we move to the noise predicting model. Similar to other diffusion model, I use the UNet architecture, but instead of UNet only consists of one down, one up, I also had a similar model just like that to processing the conditional information that is the addition of text embedding and facial landmark. And for each step, the conditional processing also add the result to the noise processing, and after each step, we reach the predicted noise. The input of the model is a noisy image, a time t, and the text embedding and the facial landmark. And after running through the model, we will receive the predicted noise that needed to subtract.
10 minutes.
Yes.
Have time more.
Yes. Now we come to the result and discussion. First, we talk about the experimental setup. I use an ADAM optimizer with a learning rate of 0.001 and then weight decay of 0.01. An activation is a Gallo activation, which is Gaussian arrow linear unit. We use it because it can accept a negative and positive value, which is suitable because we are predicting noise. So both negative and positive must be usable in the result. We also use the log function of mean square rule between the predicted noise and the actual noise added. And we apply dropout 10% with 100 epoch and 64 baseline for each. This is a learning curve. As you can see here, the model doing really well. The loss is reduced to 0 even right after 5K steps and continue in the total process. For the validation loss, we see a downward trend with no sign of overfitting, and after 50,000 steps, it is close to 0.02, which shows the model is behaving really good. I use 4 metrics: the inception score, the FID score, the SSIM score, and the PSRN score. Here is the table that I use compare our method with 2 other model, which is stable diffusion, the current state of the art, and IP adapter. As you can see here, even though we don't achieve the best in any metric, we still achieve competitive result as we can balance between IS and FID score while still have a good SSIM score. And our model also has the least amount of parameter, which is good because it reduces the time for generated image. Here is an example of a generated image from our method. Here, the form here is a list of words to describe the image. For stable diffusion, I add the text face turning left so that it's comparable to other 2 methods. For IP adapter, it can generate image really close to the original image, but just maybe too close, a little bit like color changing. For our method, even though we don't generate the best quality image, the facial structure is really close and we have more stylistic compared to the IP adapter. So we come to a conclusion and future work. Conclusion that we have developed a diffusion-based method that includes integrating the facial landmark and textual caption to generate anime style frame drawing. We also achieve competitive results and generated image balancing between the structure of the guided image and maintaining diversity. For future work, I would like to improve model performance by trying different architecture, training model, and data set. I also want to improve the model across different style, for one question, and try to expand to full body instead of just frame only. And this is the end of my presentation. Thank you for listening.
Thank you. Yeah, 13 minutes. Next, I would like to invite students for comments and suggestions. Lady first. Okay. Okay. So, of course, I'm the reviewer, but I am also the chairman, so I would like to invite first. So, if you still want the reviewer to give comment, so the reason, what is the reason why you reduce the complexity of the models? It means that you reduce the number of parameters.
Yes.
Why don't you use the same number of parameters compared with other models? So is that possible? Because I see that in the training curve and the validation curve, the progress of training is still good.
Yes.
And there's no sign of overfitting. Have you ever tried to increase the complexity of the model so that the performance improve?
Yes, I have tried that, but because the limitation in hardware, I increase more.
What is configuration of your hardware?
It is GPU 4090.
And it's strong enough. And you repeat it for 50K iteration, and the progress is still improving, right?
Yes.
Yeah. Coming back to the comparison, you have several measure. IS, for example, the previous slide. Inception score. Explain us about the inception.
Inception score is to measure the quality of the generated image. As it ranges from 0 to infinity, with higher becoming better.
Okay.
And higher means that the image following the text description more closely while still having a variety in the quality. It is calculated by putting the generated image through an instruction net v3, which is the model that used to convert the text into a vector. And we compare that to the ground truth image, and we compare two vector. If the vector is really close together, then the insertion score is higher, so that the image following the text.
Yeah, because I think that the insertion score is rather subjective. For example, for this people, it's more nature. For other people, it's not. Yeah, so like nature. So it means that the insertion score is not a subjective measure.
Yeah, the calculation I added in the report and it's in the thesis.
Because it's rather difficult for us to understand what is the insertion score. Is subjective or negative. And one step, you get it in a different way is that you remove out the very common keywords in the text corpus, right?
Yes, because I don't want to overfit it. We have to learn over.
Yeah, so it makes you lost information. There are many other common way to filter out common words, not meaningful with many words. For example, you use DF and DF weighting scheme. It's much common way and smarter way to just remove out the high frequent keywords, right? So you have this idea of filtering out keywords, right?
Yes.
How do you think about the TF-IDF weighting scheme for the text description?
I think
Have you ever think about it?
I do, but because at the time I didn't have.
Did you discuss with your supervisor about people processing the text like this one?
Yes.
And he agreed.
Yes.
Yes. Now, please coming back to the comparison table. The sunset is the same verb. Not yet. Yes, this one. So from all three methods use a prompt like smile or
the same
mouth.
Yes.
Yeah, the same. And conditional information is about just face to the left.
Because the stable diffusion only accept text and it generates the image, so
I see.
have text.
And you use more information, not only the image but also the landmark.
No, this is for better visualization because if I really array point
It means that the landmark is generated or it's described by your model.
so the landmark is actually only a black and white image.
Of course, yes.
So only have the point here.
Where do you get the landmark? Automatically from
because the data set
I saw that.
it already have a label in
it is like you still have many space and you should put the illustration of the data as a label of your data. Because right? And conceptually, which one is better for this case?
I mean, I like this the most.
Yeah, so that's why something, good and better is rather subjective measure. So is there any subjective measure conducted in your experiment? No, because a lot of images and you have to ask a lot many questions, so you don't have subjective. And according to your perception, so the middle one is the best or the left one?
The
right one. Yeah, I don't agree about that. Because this is rather some kind of art, so that's very subjective. So you should consider about some subjective measure to see how, to measure the quality of. So that's all my comment. I think that you did a good job, great job, work, and you master many things, and you present very frontally, but it lack of emphasizing on important and very interesting point. Yeah, good work. Thank you. Next, please.
Okay, so I just add some comments about your presentation because I haven't so it's really difficult to follow where your main points. I glance on the report and I see that you have an introduction, 18 pages. So it's quite a lot for an introduction. You see the structure of your.
Yes, yeah, it's the case.
Okay, so the introduction is just 2-3 pages, for example. You put the background and literature review everything inside. And I think it's better you explain more the parameters that you choose, or why you choose that. For example, I see the number 24 points. I don't see why 24. Can get another number. So we need some explanation, justification. It would be better. That's all.
Okay, thank you. So how about have you tried with different number of landmarks?
I also try with the more landmark to try the more of the round ending of the page, but
It does not improve.
It does not improve that much.
Okay.
I have a question. Firstly, I don't see any workflow in your report, also in your presentation, so I don't know which is your contribution. Which one you contribute the most? So I still have another question. So you have some metric to you have some metric to evaluate the image, right? I have a question. You have a text caption. So do you have any metric to evaluate the generic image? The generic image is exactly what the caption said.
So yes, it is the inception score is what somewhat describe it. It also describes the variety of image higher inception score. Means that it follows the text more. The structure similarity index measure that measure how close it is to the facial landmark.
Do you have any other metrics? When we do research, we use like 2 or 3 or 4 metrics to evaluate our research. Now we want. So do you have any idea about any other metric? Or only just this one? Only.
Okay. So my last question: what is your plan after graduation?
I'm trying to apply for scholarship in abroad, maybe Europe, maybe.
Maybe it's not.
Yes, I'm still finding school, still having a lot of choice.
Yeah, it means that now you have no offer for your job or your scholarship currently.
I mean, I have applied for a job and they after a good interview, I think they have responded back to me a few times, and I think I can get that job.
And your plan is go to work for the company or?
No, my parent is in Haidương. I'm getting a job here.
Yeah. Okay. Do you have any question for us?
I currently not.
Okay, thank you. So brief work. Thank you.